Thank you. Wow, I'm super excited to be here today, and I'm glad to see you here. Thanks for taking those crazy stairs to come here. Honestly, when I saw them this morning, I was like, if I see one person to my presentation, I'm golden. So thanks for going through the trouble. Today, I will present to you about DynamoDB, and more precisely, some untold stories. And why I'm saying it's untold stories, it's because I want to talk about some of the mistakes we've done at Trustpilot. And it's not something that you usually hear. Like, everyone comes to conferences and they present the success stories, like everything is perfect. And especially with social media nowadays, everything looks so perfect, and I want to share with you that things are not always perfect, and it's fine to make mistakes as long as you learn from them. And yeah, today I want to share with you some mistakes that we've done, and hopefully you'll learn from that. But before we jump into that, I should introduce myself. My name is Timofte. I work as a tech lead at Trustpilot, and I've been with the company for 5 years, which in Trustpilot, it's a lot of years. But I really like it there, and I'm looking forward to share these stories with you. And yeah, I should mention, if you guys want to reach out, you can add me, follow me on Twitter. My Twitter handle is just my name, Angela Timofte, very original, but you can find me there. And on LinkedIn as well, I'm using my name again. But let's look at the agenda I prepared for you today. And this is not working. That's great. Yes, cool. So I will start with telling you a bit about Trustpilot. I really hope everyone knows about Trustpilot. Can you raise your hand if you know about Trustpilot? Ooh, yes, nice. For those of you who don't, I will just tell you briefly who we are and what we do. Then we'll jump and look at the infrastructure that we run at Trustpilot. And then I'll go and share some juicy details about our journey with DynamoDB. And in the end, I will share how to model some real life data in DynamoDB and how you can do it the right way. And we'll finish up with some lessons that that we learned from using DynamoDB. So, Trustpilot. Trustpilot, it's an online review company. We collect reviews about companies. So, if you had an experience with a company, or you want to buy something online, you will go and check on Trustpilot and take an informed decision. And it's also very important to say that if you had an experience, it's important to go and share with everyone else so that some others can take an informed decision. Trustpilot was founded in 2007 in Denmark, and it grew to now we have 8 global offices and more than 800 employees. And I also took a screenshot of our homepage in case you've never seen it. It's very nice and pink, so I like it. But before I jump into the infrastructure that we use, I want to share some numbers. And the reason why I want to do that is because I've heard so many times people saying and asking me, it's just a website. Why do you need so many people? Why are you guys complaining? It's just a website. And I want to tell you that it's more than just a website. And if we look at some of the numbers, Trustpilot at the moment, I checked this number last week, we have almost 80 million reviews. That's a lot of data. And if you look at the graph from the beginning of time, that number just went up and went up by a lot. So, and if you look at 2020, we predict that, again, the number of reviews will just go up, hopefully. But that comes with a lot of challenges, of course, like all this data brings challenges and problems, of course. And if we even zoom a bit more on these numbers, I actually looked at the number of reviews we received in December 2019, and I compared it with 2 years ago, same month, and that number just doubled, like exactly double. It was very nice to see, like 2.4 in December 2019 compared to 1.2 2 years before that. So scaling is very important for us at Trustpilot because we need tools that can scale with this load. I mean, as a business, this is amazing. We are doubling the number of reviews, the data we have more customers, so it's amazing. But when it comes to technology and developers, this brings challenges. And even though we want the company to grow, sometimes we're like, damn it, it's growing again. Like, what am I going to do? Like, I need tools that can grow with this. And I don't want to change the technology every day because Trustpilot, it's growing, right? So if we look at one more number, this is the number of views we get for just one page that we have, and it's more than 35 million in a month. And that's a lot. And again, this is something that we have to consider every time when we add a new feature, when we choose a new technology to use. Because we can't just say to users, well, we're sorry, we have reached 35 million, we can't show you the page anymore. Like, wait in line until our product can scale. We can't do that. And as I said, that comes with challenges, and it's something that we have to consider constantly when we choose a tool. But now if we move a bit closer to look at the databases, because that's something that I want to talk about today, we'll look at the infrastructure we run when it comes to storage. And you'll see here a list of many types of databases. And even though today I want to talk about DynamoDB, and if you look at the numbers, you'll see that our top choice is DynamoDB, still we have a flavor of other databases because you should always choose the database for your purpose. And that's what we're doing. We can, at Trustpilot, we can put majority of our data in Dynamo, and I'll share with you at the end like how you can model data that you might think you can't put in DynamoDB, but still consider all the databases that are there to see which one can actually answer the what you're trying to do. And you'll see there we have also MongoDB, but we consider that legacy, and we're actually looking at ways to move away completely from MongoDB. And saying that, I want to give you a bit of history of databases in Trustpilot. So when we started in 2007, we put our data in MySQL unmanaged database. At that time, we just cared about developing a product. We didn't care about data. We had no data, so it didn't really matter. But soon, as the product started to gain some traction, we noticed that MySQL wasn't the right choice for us, especially an unmanaged database. So that's why we decided to move to MongoDB, which was built exactly for what we were trying to do, was built for web scale. So we decided around 2011 that we'll move all of our data from MySQL to MongoDB. And that transition took quite some time. We actually finished at the end of 2017 to move all of our data from MySQL to MongoDB. But actually, even before we finished moving everything in MongoDB, we've started to see issues with MongoDB. because it wasn't scaling as much as we needed anymore. And was also taking a lot of time from our SRE department to just maintain the clusters in MongoDB. Was also quite frustrating as a developer that every time when I needed a new collection in MongoDB, I had to reach out to our SRE department, which was frustrating and was taking time. So that's why around 2017, we said, okay, it's time to look for a different solution. And that's when we started looking at DynamoDB. And that's when our journey with DynamoDB began. And I would like to say that everything was perfect. We moved to Dynamo, done. But it wasn't really the case. And we're more like this. We're like, what? From MongoDB? We've got to be so comfortable in MongoDB that when they said, like, OK, now to DynamoDB. All right, but how do we put this document in this key value store? And how do I put my indexes and all these complex things? And how do I store lists? And we had so many questions, and we had no experience with DynamoDB. So we start looking at it, and we're like, we got it. It's just a key value store, right? Like, we just save some data in there, and we'll do its thing, and yeah, we're happy with it. And just like the girl there, we didn't really get it. And that's when we started to see things like this, where we were just getting spikes. And this DynamoDB that was supposed to scale up and down and we're supposed to pay only for what we're using wasn't really doing that. And yeah, it was frustrating. So we went back to look at how should we use DynamoDB. What are the patterns that we have to use with DynamoDB? We should probably not scale this database, right? We should probably look at how we set the indexes and questions like that, so that we don't just pay for something that we don't use, and we use DynamoDB, which is supposed to scale up and down and only pay for what you're using to do this. So moving on, this looks better, right? It does provision for what we're using, but not really. I mean, if you look closely, the blue line, by the way, it's what we consume, and the red one, it's what it's provision. And when I looked at this graph, I was like, why do we provision so much more than what we're using? Like, what's the deal there? And I looked at how the autoscale was set, and then I noticed that the target was set to 20%. So we actually set up this DynamoDB table to scale whenever we were using more than 20% of the capacity. So that's why you see in this scenario that we provision a lot more than what we're using. And I've seen this kind of pattern being used when, like, you know, the service, it's spiky and it's very sensitive, and you know, for like this short period of time, I just want to scale more than I need. I just know I have that need, and I'm okay with it. But looking at this is a 2 weeks period. I couldn't see that, so I just went and asked the team that owns this table to just ask, okay, what's the use case? Did we find something that like DynamoDB can't do it? Like, I was actually pumped about that. I was like, whew, I'll find something cool. But it wasn't the case. They actually told me that 6 months before I asked this, they ran a script and they needed to scale much more than they needed. And then they just forgot to update the auto-scaling. And I was like, oh, great. Okay, so it was nice why we're paying a lot more than we needed. And even though we're paying a lot more, this is a very cheap table still. It was like, I think it was $20 per month. So it was cheap. But in principle, it's not nice. Like, remember to go and change the auto-scaling, or you can do something else, like use on demand, where Amazon will just do it for you if you know you're not going to remember, or you don't know how to provision things by yourself. And now if we move to the next slide. Well, earlier I said it wasn't a big deal. The table was cheap, so fine, we're paying a bit more, but it was insignificant. But if we look at this one, well, this one, it's expensive. I don't know if you guys see, but it goes to up to 6,000 write capacity. And that's not the only problem. I mean, if you need that, sure, go for it. It's an expensive table. It's something that we need. Fine. But then I looked at the provision pattern, and I can see that the auto scale is set to go to maximum 2,000 write capacity. And you might want to put sometimes a cap, because if you might say, okay, I don't care about what's happening, I still don't want to pay more than this. Like, maybe sometimes something crazy, you deploy something crazy in production, and your table will just go nuts. So you might want to put a limit there. But in this case, I was like, okay, why aren't we doing something? It's like for 2 weeks, this table is throttling, and it's also a very expensive table, so probably we want that data. We don't want to just leave it around. So I went and investigated a bit, and I started looking at how the items looked in that table. And then I noticed we had an index on review ID, and then you can see we have feature scores, which is a list, and it has 161 items, and then labels, which is another list, and a version number. And then I opened that feature score list to see that it's a list of maps. And in that map, we store some information. And I mean, just one item was like 16 kilobytes, which is not great. When you read and write, you're already using like 4 read capacity. When you put a lot of load, well, you kind of get to what we've seen previously. But then I also looked at how we use this data, and I noticed that actually every time so in that list, every item actually has that list of 161 items, and that list is with actions that you can take on a review. Like, I know, a user is updating a review, it's creating a review, that's anything to a review, right? And that happens often, and what they were doing was to read this item based on the review ID, update one of the items in that list, and then write it back. And that's just not a good use of DynamoDB. You shouldn't do that. And that's how we actually got to what you've seen here. We're paying a lot of money, which still in DynamoDB is not that much, but it was a big percentage of our entire bill for DynamoDB. So why would we do that? It's just not great. And not just that it's all about the money, but like, you don't get the items in time. It takes time because you're throttling some of that data. So it's not a good pattern. But now I told you a bunch of how not to. And I want to share a graph where things are actually looking pretty nice. You can see how DynamoDB is just provisioning for what we need, and it goes up and down. And I really like that. It looks very pretty. But now imagining doing something like this on a traditional database, where you actually have to provision for your spikes. So in our case, you see there's a huge spike there of like 15,000. You'll have to provision for that spike. And then you pay so much for what you're not using. And that's what DynamoDB is great for, and it's great for us, the way we scale things and the way we see our patterns. But now I want to move to look at how should you model some data in DynamoDB. And in this table, we'll have a business unit ID, and each business unit has a list of ranked categories. And you get a country ID, you get an identifying name, a trust score, a review count, and a status. And the status can be claimed, collected, and unclaimed. And the first thing you should actually do when you talk about NoSQL database in general, and of course DynamoDB, you should look at your queries. So what are the queries that I want to do on this data? So I want to get a list of businesses for a specific category, and I want that list to be filtered by a category ID, by a country ID, the number of reviews, the status, and this list should be ordered by trust score and review count. And the second query that I want is to get a list of categories for a specific business by the business unit ID. And just to show you guys, since we're cozy here, this is actually real data. We actually had to do those queries. And if we go to trustpilot.com and you go to categories, I hope this works and we're not going to get like a 500 and be like, oops, I need to go and fix some things. And if we just take a category, this is the list that I actually want to build. I want a list of categories based on a category. In this case, it's pet supply store. If you need that, you can go and check the companies. And this list can be filtered by, as I said, number of reviews, the time, and the status. And now going back, not to that presentation, that's another presentation that I done at some point. Going to the right one. So how can I do this in DynamoDB? And I should actually tell you guys that first, we modeled this data in SQL, in Aurora, because we're like, oh, these queries are so complicated, we can't do it in Dynamo. And I should say I simplify. There are actually more queries, but just to explain the pattern, I just went for these two, but it's similar. If you understand these two queries, you will understand the others. So I just simplify a bit. But yes, when we first put this data, we're like, no, we're just going to use SQL because it's too complicated for Dynamo. And it's not actually the case. So now if we just put that data in like a table, you have the business unit ID, and then you have that categories IDs, which is a list, and all the other things. But I know I want to query by a specific category ID, so I know for DynamoDB it's not that great to have a list. So let's go and split that. So I'll save like an item with business unit ID and the category for each. And I split that up. And if I put the business unit ID as my partition key, well, that's not unique, right? So in DynamoDB, you have sort keys. So, OK, let's go and add the sort key. I can add the category ID as a sort key. And now it's unique. I can save it like that. But if I look at my queries again, well, I don't have any query where I will give the business unit ID and the category ID. Like in my queries, I either give the business unit ID only, or I give the category ID and give me the business list. So this doesn't work. But why not start with the idea of that category ID? I mean, coming from MongoDB, honestly, we always think like, OK, you need that identifying object, which in our case, in other tables, was the business unit ID, and we're like kind of like this, you know. So let's try and spread our view. And let's move that category ID, because that's what I want to query, right? So is that my partition key? But of course, it's not unique. And I know I don't want to add the business unit ID as my sort key, because we're just seeing that doesn't make sense. But if I look at my query again, and if I look at the first one, I can see that I want a list of businesses for a specific category. So I got that. I got the category ID. Filter by some things. And I want it to be ordered by trust score and review count. So why not put trust score as my sort key, right? And I'll move that there. And now it's my sort key. And I'll get that list sorted by trust score. But again, that's not unique. And I actually want it sorted by trust score and review count. So let's try some crazy things like this. Ooh. Okay, so now actually in my sort key I have the trust score and then I have the review count. So now actually I get that list sorted by the two things that I wanted the list to be sorted. Crazy. But now in the real life, I know that it might happen in one category to have companies that have the same trust score and the same review count. So this is not unique. So let's put that identifying name. So now I get the list that's unique now. And it's also ordered by trust score, review count, the way I want it, and the identifying name. And just with this, I can actually answer to the first query in a nice way, right? I can give the category ID, and I'll get a list ordered the way I want, and then I can put some filters like, okay, give me the list to be filtered by the country ID, the number of reviews, and the status. I can just finish there. But I think we are onto something. I know I also give that country ID every time, so why not put that in the sort key? Because I know in DynamoDB you can query, you can say in a sort key that it begins with 1, and then it will just give you that. So I can just give the country ID in the sort key, and now I get the list for that category ID, for that country, ordered by the things that I want it to be ordered. But I also know I can give the status. And I just got my query. The first query, it's done. I can get on that partition key with that sort key exactly the results I want. And this query, I know it's going to be fast. And I'll get my responses really quickly. The only thing that I couldn't put in that sort key was the review count. So I'll have to actually filter by that. But I know by the time that I'll filter those results, the amount is so small that I'm okay with doing that. And then if we look at the second query, I also want to get a list of categories for a business. So on that one, well, I don't know what happened there. But on that one, I'll just add the global secondary index on my business unit ID. And very important, I'll only project my categories IDs. And then the results will be smaller. So I'm going to use less read capacities units. So I think that's just beautiful. I'm very proud. And I hope I made it clear enough so that you just understand this pattern where in the sort key you can put so many things and you can filter so nicely that even queries that look complicated in the first phase, you can actually achieve it in DynamoDB. It's just a matter of like playing with these things. It wasn't as easy as I showed you right now to get here. It was like, yes, category IDs, and I moved that, and then, no. It took me a couple of minutes or hours to get to this. But I was very happy once I got here. And as I said, on this data, we actually have other queries. But once I got this query, I was like, oh, now it's easy. All the others were were literally easy. So it's really important to just play with DynamoDB and try to do things, and you'll get there. You'll see that even complicated things are actually achievable with DynamoDB and with the things that they do. And now I just want to share some lessons. It's just blank. Those are the lessons. No, I want to share some lessons that we've learned from using DynamoDB. And I should mention, we're still learning. We're still making mistakes. Some of the graphs that I show you, they were recently. So yeah, we're still learning. But you have to understand, DynamoDB is kind of a shift in the way you look at the data. We're kind of programmed, I think, to think in a SQL query. That just makes sense, at least for me. But with DynamoDB, it takes a bit, and it takes practice. So just give yourself some time. Then another lesson that I want to share, if this will work, is that you need to know what queries you want to make. You can't just, with NoSQL database in general, you can't just put your data there and be like, yep, I'll figure out what I need later. You can't. You really need to know when you store your data, you need to know how you want to take that data and how you'll use it. So make sure you start with how you are actually going to use this data so you have the right way of modeling your data. Then you should not scan your tables. I mean, if you have just a few items in there, yeah, you can go crazy. You're not going to see something insane, right? But we've noticed in our scenario, when we start to have more data and do more things, well, small mistakes are noticeable. And that's the case with scan. Like, try to make your queries so that you can just do it on your indexes and not scan your tables. And when I say scan your tables, I also have to mention that DynamoDB is not for analytics. And you shouldn't adopt it that way. I've actually seen people thinking, oh, but how can I store this data so I can analyze it? Well, DynamoDB is not built for that. Like, if you want to analyze your data, do it somewhere else, not in DynamoDB. And actually on that one, I've seen recently on Twitter, someone was asking what's the preferred way of saving data types in DynamoDB, if you want to save UTC or a timestamp. And people were like, oh, I like to save UTC because then I can actually understand that data. If it's time stream, I can't just calculate what are the milliseconds from 1970, right? But I was like, but why do you care? Like, your DynamoDB is made so you can use it in your services, which can calculate that timestamp easily. Why do you make your data so that you as a human can just read it? Like, if you want to analyze your data, move it somewhere else. Don't do it in DynamoDB. And one reason why you should, like, people were still considering timestamp was because in DynamoDB, if you want to add TTL, a time to live, you can only do it on that type, on timestamp. Then something else that we've definitely learned is that you should verify your scaling policy and check if you should use on-demand instead. And I actually had the conversation with my colleagues when I've seen some of those scaling policies, and it wasn't the only one where I've seen that we actually provision more than we need. I asked, well, why don't we just go to on-demand? I mean, on-demand, it's slightly more expensive, and that's one of the reasons, especially like one of my colleagues said, like, well, if you know how to provision correctly your table, then you should just define the provisioning. You shouldn't use on-demand. And I was like, well, I totally agree with you, if you know how to do it correctly. And we've seen we don't really know how to do it, and we forget. That's that was actually the main problem with us. Like, we've done some changes, we changed the auto-scaling, and then we forgot to update it. And maybe you want to test, like, which one should you use, on-demand or provision, see what's the case. Maybe you guys are like, have perfect memory and you know how to go and update the policy. Apparently, Trustpilot, it's a struggle. But yeah, consider on-demand for sure. If you don't know exactly your how to provision your table. Then it's very important how you read and write, and you should definitely project only the information you need. You've seen in the example I gave you, like when I just need to query by business unit ID, I put a global index on a global secondary index on that, and I just project the information I need. I shouldn't just project everything just because it's there. Just project what you need. And the last one, which I really like, if it's expensive, it might be because you're doing something wrong, and you might want to investigate. It might not be the case, but usually it's a good indication based on the experience that we had with DynamoDB. It's usually very cheap, so if it's expensive, have a second look. And with that, I'm done. Thank you very much for listening to me. And yeah, if you have any questions, I'll be around. And if you have questions now, I think I still have 4 minutes, maybe?
Couple of minutes.
Yes.
Any questions for Angela?
Don't be shy.
Don't be shy. Yeah.
I saw that you had 104 tickets. Oh, sorry. Let's make it official.
Hi, my name's Stefan, first-time viewer, long-time listener. Yeah, you said, so just off the bat on your presentation that you had 144 tables. Is there any particular reason for that, or is it just like distribution of the load? Or is it actually 144 separate tables?
Yes, there are actually 144 tables. One of the big reasons why we have so many is because in Trustpilot we develop all of our services. We apply microservices, and then we split them in contexts. So we do have many, many contexts that we don't just share the data. We share the data through an API, but we usually just prefer to have the data close to the context. If, for instance, the example that I showed to you, the categories, well, the data about categories will just live under that context. That will mean one specific table just for that context. And then it just grows from that. So that, I would say, it's the major reason why we have so many tables. Yes. Cool. Yeah, there's someone there. I can also repeat the question, so you don't have to run, but yeah, thank you.
Hi.
Hey.
A question on when the data structure change. For example, on the page you showed that you have a couple of filters. If you need to add another filter, for example, in the future, and then a second one after that, for example, how do you evolve the data schema? So basically, do you need to go through the whole table again and append basically the field on the sort key, and then again after that? Or do you have any insight on this kind of problem? Thank you.
Yes. So yeah, if your queries are changing, you need to change the way that you store your data. In the one that I showed you, for us it's very easy to change it because we update this table daily with information, and we can just change the structure completely. So yeah, you'll have to add a new index probably if your schema is changing, so you make sure that you get the data as fast as possible. Yeah.
Final question.
I think
1 minute left.
1 minute, one question.
More non-shy persons.
All right. Otherwise, I'm around. Oh, someone.
So are you happy with your replacement for MongoDB?
I'm just happy in general.
The question was, you migrated then away from MongoDB.
Yes.
Now, are you in general happy now with that way?
Yes. We are very happy with that. And me as a developer, I'm not a database expert or anything like that. I'm just a full stack developer, and I'm super happy that me as a developer can go and do these things by myself. I don't need someone else to hold my hand to go and create the cluster, take care, maintain the MongoDB cluster. That was actually something that was happening constantly. Like in the middle of the night, our cluster was just going down because we were having too much load on that specific collection. And then the poor guys in DevOps, they were waking up and looking, okay, we have to scale up or down, or what's happening. So very happy about not using MongoDB. So, yeah.
Thank you very much, Angela.
Thank
Thanks for
you.
sharing.